At first glance, these chemical reactions might seem like a mess of information, but there are patterns among them. It's helpful for chemists to sort all the chemical reactions into categories so that they can make predictions about how chemicals might react. There are 5 main types of chemical reactions: combination, which is also known as synthesis, single replacement or single displacement, double replacement or double displacement, decomposition, and combustion. Now, not every reaction falls perfectly into one category. Sometimes a reaction falls under 2 categories, but there are some very key features of each of these categories. Let's start with combination reactions. Combination reactions combine 2 or more substances to form a new single substance. This example is elemental magnesium and oxygen combining to form magnesium oxide. The 2 elements combined and formed one ionic compound. Even though it made 2 units of magnesium oxide, they're the same substance. So here we have the balanced chemical equation, a particulate drawing of that same reaction, and now here's a general equation for combination reactions. A plus B yields substance AB. The reverse version of this kind of reaction is called decomposition. In this reaction, things fall apart instead of coming together. A single substance breaks down into 2 or more simpler products. Here's an example of hydrogen peroxide breaking down into water and oxygen. Usually, decomposition reactions need heat or fire or electricity to get started. This reaction can happen quickly with a catalyst like yeast or manganese dioxide. So we have the equation, a drawing, and now a simple formula for decomposition. AB yields A plus B. The resulting compounds are smaller and simpler than the starting compound. Let's look at the next type of reaction. Single replacement. In this reaction, one element replaces a second element in a compound. We'll use the example of zinc reacting with iron chloride to make zinc chloride and elemental iron. The 2 metals in this case have swapped places. So here we have an equation, a drawing, and now a simple formula for single replacement reactions. A plus BC yields AC plus B. But not all single replacement scenarios actually work. In order to see if the swap will occur, we need to reference a chart, the activity series of metals. The more active metals are toward the top, and metals decrease in their activity as you move to the bottom. In the previous reaction, zinc was the individual element, and it was higher than iron on the activity series. So this reaction occurred. But if we tried to react elemental iron with zinc chloride, nothing would happen, because iron has a lower activity than zinc. Now let's look at the next type of reaction. Double replacement. This reaction is similar to single replacement, except we're starting with 2 compounds. The reaction has an exchange of positive ions between 2 compounds. In this example, copper 2 chloride and hydrosulfuric acid will swap their positive ions to make copper sulfide and hydrochloric acid. So here we have an equation, a drawing, and now a simple formula for single replacement reactions. AB plus CD yields AD plus CB. You can see from this equation that A and C have just switched places, and those represent the positive ions. Usually, a double replacement reaction creates one of 3 products: a precipitate, a molecular substance, or a gas. In this double replacement reaction, we started with 2 aqueous solutions and end with aqueous hydrochloric acid, but solid copper sulfate. This will sink or precipitate to the bottom of the container. Another possible product would be a molecule. In this example, we start with aqueous substances, but one of the products is a liquid, the water, and the other product is still aqueous. Lastly, another possible product from a double replacement reaction is a gas. Again, we start with an aqueous substance, sodium cyanide, sulfuric acid, but form a gas as a product, poisonous hydrogen cyanide gas. Don't try this one at home, folks. The last type of chemical reaction is a fun one, combustion. In combustion, an element or compound, typically a hydrocarbon, reacts with oxygen, often producing heat or light. So here's the combustion of a hydrocarbon called methane. The combustion with a hydrocarbon will always make water and carbon dioxide as products. This makes predicting the products really easy in this case. So here we have an equation, a drawing, and now a formula for the combustion of a hydrocarbon. Don't be intimidated. The x and y variables here provide a shortcut for balancing the equation as well. But not all combination reactions happen with hydrocarbons. The combustion of magnesium in oxygen is both a combustion reaction and a combination reaction. Remember, there are some reactions that can fit into more than one type of reaction. Thanks for watching this episode of Teacher's Pet. Don't forget to like and subscribe and follow me on Twitter @SciencePet.